Hello everyone. तो चलिए स्टार्ट करें फिर आज का सेशन. होप ऑडियो एंड स्क्रीन इज विजिबल टू ऑडियो. एम आई ऑडिबल और यस एंड लेट्स स्टार्ट इट. So so already I think that you already have enrolled yourself into the course that is basically in the course section, so that if you haven't enrolled eh, yourself, then you can please enroll it first, because after the session you will get this recording in this course 5-day free CCNA workshop, so that it will help you to get recording without any interruption. और इसमें कोई दिक्कत होती है तो फिर हम लोग बैठे हुए हैं, आपकी हेल्प कर देंगे. फ्री कोर्स है, आप इनरोल करेंगे एंड आपको वहीं पे सेम डेट सेम टाइम अपडेट आना भी स्टार्ट हो जाएगा. जब भी रिकॉर्डिंग प्रोसेस होगी और बाकी सारी चीज़ें होंगी तभी आने स्टार्ट हो जाएंगे, ठीक है. तो एक तो ये है. दूसरा, देन इफ़ यू गाइज आर वॉचिंग ऑन यूट्यूब, देन वहाँ पे भी अवेलेबल रहेगा. तो 2-3 मिनट और वेट करते हैं, 2 मिनट और देन स्टार्ट करते हैं. ऑलरेडी हमारे यहाँ पे आप चेक करोगे तो कोर्सेज के अंदर रिकॉर्डिंग्स ऑलरेडी है. या आई कैन स्पीक इन इंग्लिश कॉप्स, सो नो इशू. थैंक यू. सो and you will get everything there, okay, like either it is document related notes or videos. You will get everything in course section only. So during the class I'm not going to check the chat, and I will check uh, after some time. So hope you guys understand about it, because I am working on a single screen, so it's not possible to watch everything. So let me start it, the day 3 of our this class. And today we are going to discuss about layer 2, layer 3 switches. Hope you guys understand about layer 2 or layer 3 switches, how it is actually physically how it is look like. So today we are going to discuss about in a brief, so how it is going to be function in our network, and what kind of thing we can do by using this kind of switches. If we will have time, then we will discuss about access point as well. If not, then we are good to go. Okay, and let me start today's session. So first of all, let me open the presentation so that it will help us. So hope screen is visible, right, to everyone? Like are you able to see the screen properly or not? Just please. Yeah. Okay. So yeah, thank you all, and let's start today's session. So what is this? Okay, leave it, whatever it is. So welcome guys, welcome to Networking Scholar, and my name is Ramesh Kumar Sharma, and today we are going to start our day 3 session of pre-CCNA workshop. So basically we have already covered 2 session in last week on Friday and Saturday and Sunday about computer network, and computer network as well as how they are working, like physical devices, how it is look like, and various thing was covered in that videos, and if you haven't watched, then you can watch on YouTube as well as. And you have one more option, you can enroll yourself in the course and you can learn from there. So today we are going to discuss about layer 2 and layer 3 switch. So basically layer 2 and layer 3 switch is what? One second, let me take a pen. Today I'm going to take a blue pen. So layer 2 and layer 3 switch, what it is doing, suppose that we have an user, not only user, suppose that hundreds users are there. Okay, 100 users are there in our network, and they all wants to communicate at a time without any failure or without going anywhere other network. In that case, what we are using switch. Just it will create a simple VLAN or simple network, simple broadcast domain, and uh, that will help us to share information between source to destination, or we can say that between one PC to another PC, one computer to another computer. तो जैसे कि बीच बीच में मैं हिंदी भी लूंगा, बिकॉज कुछ लोग हमारे साथ हिंदी में भी हैं। तो एक से, जैसे हमारे पास दो पीसीज हैं फॉर एग्जांपल, और या फिर दो से ज़्यादा या 100 100 यूजर्स हमने ऑलरेडी कनेक्ट किए हुए हैं, ठीक है। तो उस केस में क्या होगा कि हम एक स्विच को यूज़ करेंगे और स्विच स्विच का एक नेटवर्क बनाएंगे। डेफिनेटली ये सपोर्ट नहीं करेगा 100 यूजर्स, सपोज दैट 24 पोर्ट या 48 पोर्ट की होगी। इट कुड बी 24 and 48 पोर्ट, ओके। तो दिक्कत यहाँ पे बढ़ने वाली है जब जब आप मैक्सिमम स्विचेस कनेक्ट करोगे। फॉर एग्जांपल फिलहाल के लिए हम ले लेते हैं कि हमारे पास 48 पोर्ट की स्विचेस, 48 ही यूजर्स हैं, ठीक है। देन ये जब यूजर ए चाहेगा यूजर बी को कोई इंफॉर्मेशन शेयर करना विदाउट एनी इंटरप्शन, देन यहाँ पे ये पॉसिबल है बाय स्विच के अकॉर्डिंग, बिकॉज एक एक टाइप का वीलैन क्रिएट करेगा और नेटवर्क क्रिएट करेगा, सिंगल ब्रॉडकास्ट डोमेन होगी। देन वी आर going to talk about layer 2 switch. So layer 2 is that this is a just a network device, it is nothing else, okay। आपको ऐसा नहीं सोचना है कि नेटवर्क डिवाइस के अलावा और क्या करें, नेटवर्किंग में क्या क्या कर और कहाँ लगा सकते हो, नेटवर्क के अलावा बाहर कहीं यूज होता नहीं है जनरली, ठीक है। तो नेटवर्क डिवाइस है दैट्स ऑपरेट ऑन लिंक लिंक डेटा लिंक लेयर ऑन लेयर 2, बेसिकली इसीलिए इसको लेयर 2 स्विच बोली जा रही है, ठीक है। बिकॉज ऑफ दैट, बिकॉज इट इज वर्किंग ऑन OSI लेयर। वी हैव ऑलरेडी लर्न अबाउट OSI, राइट, OSI लेयर 2। सो OSI लेयर 2 का नाम कौन सा है, डेटा लिंक लेयर, ठीक है। इसलिए, और ये इसका प्राइमरी फंक्शन, व्हाट इज द प्राइमरी फंक्शन, इट सेंड डेटा पैकेट विद इन सेम नेटवर्क और local area network. We already explained about it. So it is going to send the data packet between same network, okay। And it based on what, based on MAC address, media access control, basically MAC address, full form of the MAC is media access and control. So based on media access control, it is going to take a decision about it. One second, guys. Okay, then we have how it is going to look like in a network. So this is the switch. Here you can see this is the model number 2960 G series, okay। So this is a switch model number. Here you can see this is the reset button, there are few LEDs, it is showing like sync, system, NVRAM and multiple thing. Here also there is a multiple LEDs are there. Suppose that whenever we are going to connect, for example, if we are connecting something here, something in the sense cable, okay, in that case it is going to be glow like a green or yellow. We will see in a physical network only, because there is not an option to check this. As well as these are SFP module port, okay। In the back of the switch you will find the console port and power port for to turn this switch off and configure something if needed. और हम एक और चीज कर सकते हैं, इसमें एक मैनेजमेंट इंटरफेस बना सकते हैं, सो दैट हम इसको डायरेक्टली विदाउट कंसोल के भी मैनेज कर सकते हैं, वो सेकेंडरी पार्ट है, ठीक है। तो ये होती है हमारी एक जनरल स्विच, ऐसा दिखता है आपको नेटवर्क में, ऐसा दिखेगा। देन बात आती है हमारे लेयर 2 स्विच कॉमनली कहाँ यूज होते हैं, टू इंटरकनेक्ट कंप्यूटर्स, प्रिंटर्स, सर्वर्स एंड अदर नेटवर्क डिवाइसेस लाइक One second, guys. Something is wrong today as well. Access point. Access point is there. Server already completed. Okay. Switches, routers, firewall, etc. There are multiple phone, IP phone. We can use this kind of devices to. We are using this device to interconnect these kind of devices. Okay. There are many more devices as well. लाइक का पीओ इंजेक्टर हम कनेक्ट कर सकते हैं और बहुत सारी चीजें हैं. सो देन व्हाट क्या क्या कंपोनेंट क्या क्या होते हैं, जैसे कि हमने राउटर के बारे में देखा था कि राउटर में व्हाट काइंड ऑफ कंपोनेंट्स आर there in a router. Similarly, we have multiple components in switch as well. Like first is switch fabric. Switch fabric is that when it is just architecture to the it is based on that it is going to forward packet to the in the network. Okay, so this is called switch fabric. Then we have, it's consider hardware it's consist of hardware components such as ASICS, application specific integrated circuit, or we can say that FPGA, field programmable gate array. It is similar like we have learned about gate and NOR gate and gate look like that. So it is working on like that. Okay, to perform switching forwarding operation at wire speed. Suppose that something is coming for some different VLAN and we have it wants to go on another VLAN, then it will check for this kind of the thing, like it will trigger something. Okay, then there is a ports. So what is port? हमने देखा था port is that where we are going to connect some cables. Okay, there was that was 48 port switch which already we seen in the last slide. So these are the ports. So port sometime it's also called interface. Okay, okay, interface, it's also called interface, port or interface. So ports are physical interface on the switch where devices such as computer, printer, and other switches are connected. We already explained about it. So suppose that we have to connect a device, network device like a router, firewall, server, okay, IP camera, and IP phone. Okay, these kind of devices. Suppose that we are going to connect. In that case, it will all only connected. It will only connect on port or interface. Okay, such as computer, server, printer, or other switches. Like if we want to we have a switch 48 port and we want to upgrade up to 90 user, for suppose that 90 user. Okay, then what we are going to do, we are going to connect 48, one more 48 port switch here, then it will be 96 around. Okay, and one port is used for connecting between switches. Then we what how many switch how many interface we will have, we will have 94 ports. Okay, so to connect switches as well we can use the ports. Okay, we will discuss in a diagram in a just in a few seconds, after few seconds. So then what is capacity of the port? So port capacity could be 100, 10 as well, 10, 100 or 100 mbps. Suppose that we can say that 10 gigab 10 mbps link, 100 mbps link, 1 gbps link. So, or if there is a higher port, like we had, there was a SFP port, right, in the right side of the switch, there was a 4 SFP port. So it could support, it can support up to 10G based on your model number, device model number. If you have a lower model, lowest interface speed, then it can, you can use the uh, general interfaces between 1 to 24 or 20 48 ports switches. If you have more than a higher speed like 10G if you are using, or 5G 10G if you are using, then you can go with the SFP model, SFP based interface. Then there are MAC address table. So basically in the, what is MAC address table? MAC address table is the physical address of every device, physical address of every device. Okay, that is MAC address. But switch is going to take a decision based on MAC address as well. Like how, suppose that something is connected, some devices are going to we are connecting on switch. So it should have a MAC address to make a MAC address table on the switch. So because so it's called MAC address. Why it is connecting? Because it's work on layer 2. We discuss about layer 2, right? So layer 2 protocol, there are MAC address is the layer 2 thing. Okay, layer 2 component. So it will take decision as per the MAC address, and it will forward data as per the MAC address only. There is not required for layer 4, layer 3 routing and anything like IP address as well. So they are not required for IP address. Only MAC address can work here. Based on MAC address, it can take decision. But you have to think about it. ये सिर्फ on, it is not going to work only for Mac. It is not apart. Suppose that someone is thinking, if suppose that it is working for a switch, a layer 2 on based on MAC address, then other will be denied, like layer 4, layer 3 and layer 7 traffic will be denied. No, it is not going to deny. It is just taking forwarding decision based on MAC address. ये सिर्फ मैक एड्रेस के बेस पे ही फॉरवर्डिंग डिसीजन लेता है, ना कि आपका पूरा का पूरा ट्रैफिक को डिनाई करेगा और बेस्ड ऑन इसके ऊपर काम करेगा. ओके, and because of that, it's also called MAC address table, also called what? CAM, content address memory table. It is a database maintained by the switch, and that map what MAC address to interconnected switch port. Let me tell you and let me show you an example. We have 12 port switch. Okay, I'm just trying to make a diagram. 4 and 5. So here this is 1 2 3 4 5 6 7 8 9 10 11 and 12. Okay, these are the interfaces or port, we can say. Okay, suppose that something connected, that is MAC address is AA, one PC1 is there, PC2 it is BB. Okay, PCC there is CC, 3 on 3 and DD. Then how it is going to make build a MAC address table? It will make address, it will take a table like just a second guys, who is sending a message? No, I don't think so. Am I not audible? वॉइस का इशू है किसी को? Am I audible properly or not? I'm not audible. Hello, 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 hello. Hello, hello, hello. Hello, hello. Am I audible, right?
Your voice is, yeah, Ramesh, your voice is audible, but it's cracking meanwhile. Can just everyone confirm, please?
Okay.
I think I might have a network issue here as well.
Maybe. Thank you, Manoj. Basically,
All
what
right,
is
Manoj.
happening? We are streaming multiple platform, na? That's why maybe it could be a reason of that. It's okay. So you will see in the recording as well. So for time being, this is good for us. So let's okay. So how we are going to build a MAC address table? MAC address, okay, MAC address table. So we are going to discuss about it. Let me open. Where was I? Okay, here I am. So how it is going to build a MAC address? So it will build MAC address based on port and interface. So it will suppose that it will how it will going to address. This is the port and MAC. So on port A is connected. Port 2 what is connected? PB. Port 3 CC. Port 4 DD. It will look like it. It will create database look like that. Okay. So whenever suppose that something is coming, suppose that A wants to communicate D. Okay, then how it is going to work? It will check for port number. Incoming port will be 1 and outgoing port will be 4. Okay, then it will forward based on MAC address. It will send the packet based on MAC address table. How? Because we already have a MAC cam table or MAC address table, so it will take decision without any without taking time, and it will forward the packet to the destination port number. Okay, so this is called MAC address table basically. So I was, and then based on we already discussed about it, then there is CPU and memory. So what is CPU and memory actually? CPU and memory is same thing which we have, like we are using mobile phone, right? We always trying to get like how many RAM we have, how much RAM we have in our mobile phone, or how, what is the storage, like 8 GB, 126 GB, sorry, 246, 256, 128, or 4 GB, 128, 4 GB, 64 GB. So there are similar thing which is also in our network switches as well. It's called CPU and memory. CPU and memory is why we are using, because it is processing something. How it is going to process? Without CPU it is not going to process anything. Suppose that if we have cam table, but how it will create, there should be a memory or something, right, to maintain this table. As well as, if there is something database is there, then definitely we have required what? CPU to process, central processing unit to process this information into binary to decimal, decimal to binary, as per the requirements. For example, I am saying, so there are CPU and memory is there are two type of memory. RAM is able to use to perform temporary task, and ROM is able to store, okay, store what? Configuration and configurations, as well as databases, whatever it is. So it is going to be work like that. So because of that reason, we have required CPU and memory in our network. Then बात करते हम, then we are going for a next topic, that is management interface. We already discussed there is console port, then why it is management interface is required in the switch. So management interface is required for that. Suppose if console port is behind, on the back of your switch, and you always, if you have to configure something, or if you have to create a new VLAN, or you have to shut down one interface or something else, in that case you have to go and plug the console cable, and you have to first, you have to what, you have to remove the cable, sorry, switch from your rack, from your case, and after that you are going to connect the console, and after that you will configure it. Suppose that what if we have management interfaces, then what it will help, it will do, it will help us to configure without going, without removing switch from the rack, without uh, putting console on the switches, okay, switch port and console port, and we can configure it. So switch management port is working on, based on CLI, as well as command line interface or graphical user interface. It is also helping us to manage what, manage to monitor the devices and traffic as well, okay, and it will also help to what, troubleshooting issues. Suppose that, for example, troubleshooting in the sense, suppose we are shutting down interface, or we are creating a VLAN or something, in that case it is going to be work. So management interface is also important part of our switch. Then there are few more thing, that is called function. So how it is going to be function in our network, ये function कैसे करता है हमारे network में basically. तो function करेगा based on, ये आपका कुछ frame देखेगा, and then इसके बाद चीजें check करते हैं. Then first it is going to be frame forwarding. So how it is going to, what is actually frame forwarding, and how it is working in layer 2 switch. So let's explain, let me explain, and let me show you the thing. Layer 2 switch forward data frame between network devices within a same LAN based on destination MAC address. Same LAN on, based on destination MAC address. So 1 second guys, I think I am facing an issue. Video. Rahul, can I stop video? To join us, for join us, who is going to join? So stop video. Okay. So okay. Then in the same LAN, suppose that we already discussed we have 24 or 48 ports. So if we are not configuring any VLAN, then it will consider as a single LAN, and it will forward packet frame or packet hub based on MAC address table. So basically on layer 2 it's called frame. Okay. So you need to understand about it. So I will share you some cheat sheet on this course section. You will find it. So what actually packet call on each, on which layer, either it is based on OSI or TCP/IP model. Okay. So this is the thing, how it is going to work. They use MAC address table. Okay, let me erase it first. So this is using MAC address table to determine outgoing port for each frame. It will always check. Okay, it will always check for MAC address table. So you guys must understand about MAC address. If you don't know, then you can please watch this video again. What is actually MAC address? So okay, I will upload a short document about the MAC address table. So what is MAC address table and what is actually that will be in a brief. So you will find in the course section. Okay, so based on MAC address table, it is going to send frame to the destination outgoing port. Okay, am I audible or maybe it's disconnected something? Hello. Okay, I am audible, I think. Okay, thank you. So let me open my chat here. Okay, so what it is doing in it is minimizing unnecessary broadcast traffic. Suppose that we have a single VLAN. VLAN 1 is there only configured. Suppose that it is connected VLAN 1 to 21 port is configured for VLAN 1, and suppose that we have also a VLAN called VLAN 2. Then what it will do, it will not going to process frame in other VLAN. Unnecessary broadcast, this is unnecessary for this port. And suppose that 22 to 24 is a part of VLAN 2, then it is VLAN 1 is unnecessary for VLAN 2, and VLAN 2 is interface traffic is unnecessary for VLAN 1. So it is going to be work like that. It is not going to allow to forward in different VLANs. Okay, so this is the thing can be handled by switch. Then there is MAC address learning, how it is going to be MAC and what kind uh how many time it is going to learn about the MAC addresses, how much time it will take the MAC address table in their entry. So basically MAC address table entry will can be stored by a single switch or ARP entry by switch at least 4 hours. Okay, this is default setting of the switches, but you can change as per your requirement. So layer 2 switch dynamically learn MAC address by examining source MAC address of incoming frame. Now let me explain how. Okay, this is our switch. This is FA0/1, FA0/2. Okay, this is AA and BB. IP address 192.168.1.1, 192.168.1.2. Don't think about the IP address right now. We are not talking about IP address. Just focus on MAC address. Suppose that AA or 1.1 is trying to ping BB or 1.2. 1.2, why I am taking this is the IP address without at least we have to complete layer 1 to layer 7 and layer 7 to layer 1. Okay, without this it is not going to, without completing all the step, it is not going to forward as per the OSI model. Similarly, layer 1, layer 4 to layer 1 and layer 1 to layer 4, it need to be completed. Packet will go everywhere on each layer and for in TCP IP. Okay, so it needs it will complete. Till then it is not going to complete the full process or full process in OSI or TCP IP. It is not going to forward anything. So here is what, suppose that A is trying to ping BB or 1.1 is trying to ping B 1.2, 1.1 is trying to ping 1.2. Then what it will check, how it is going to work. So then how it is MAC address is learning. So MAC address will learn, suppose that something is created from here and it is where it is forwarding to. First it will go to the switch. So in this packet there will be some information like source MAC, okay, destination MAC and frame, okay, as well as source IP, destination IP. Frame in the sense packet, whatever is the data, actually data. Okay, then it will check how it is going to learn. It is dynamically learning. Okay, suppose that something is happening. I don't know what is this, but there is something. I'm getting ring. Okay, so no issue. Then Okay. So first, it will going to learn dynamically how packet came from someone. Sorry, packet is coming from one a PCA, and it is going to the switch. Then it will learn for like source MAC address. So it will create entry FA 0/1 have what source MAC address is AA, and IP port number is 0, sorry, 0/1. Similarly, it will what first it learn, okay, if for a prompt where incoming data frame, it is incoming data frame, it's learned, and then it will check for other MAC address or other IP address. So we are using just L2 switch, so we are just focusing on MAC address. So after that, it will create for what? It will create. It will check. It will allow us to share information. It will allow us to get the MAC address of BB. So it is some kind of R process. So we will discuss later about it. Okay, so how it is going to be learn about from incoming data, from incoming data frame. When the packet is arrived, the frame is arrived at the switch port, switch will update MAC address table. Okay, definitely suppose that some we have changed our PC on fast Ethernet 0/1. Then what it will do? It will again it is going to the same thing, and it will update the MAC address table and it will remove the last enters. For example, the new PC MAC address is ZZ. Okay, then it is going to be remove the entry of A, and it will add a new entry on fast ethernet 0/2, oh sorry, 0/1, that is ZZ. Okay, with the source address and corresponding port information, allowing to build forwarding database for future frame forwarding. So suppose that till then this PC is connected on FA 0/1, everything will be good, and it can be shared by it can share information without losing any frame or something, we can say that. Okay, then there is broadcast and multicast handling. So broadcast is what? Suppose that if we have we it is not going to support. Suppose that we are using hub. So earlier in the few years back, there was a hub already also in a network. So what it is doing, it is also trying to send frame every interfaces. So let me explain. It was sending, suppose that we have a PC, we have 5 PC connected here. Okay, so suppose that this PC is trying to send some information on, this is 1 2 3 4 5. So oh sorry, one is trying to send something on 3. Then what is how what it was doing? It was sending frame to the every interface every time. Or suppose that 4 is trying to send something on 5, so it should be direct go to the look like this. Okay, but what is it is doing? It was sending to every interfaces. So it was what it was doing, it was sending it was creating a broadcast, and it was saying unknown annoying uh it was doing annoying thing. So to reduce this thing, it is also help us layer to switch help us to uh, remediate the thing, like it will disable like broadcast and multicast handling. So layer to switch handle broadcast and multicast traffic by forwarding this frame to the all port within the same LAN. If it is in same LAN, that then it is fine. If it is not in same LAN, same virtual local area network or same local area network, then it is going to be discard, except incoming port. Suppose that something is coming from FA0/, so it is not going to forward that frame or that broadcast frame to to this interface, because it's know about it. So it is coming, the frame or packet is coming from FA0/1. And let me erase it. Then we have, it will ensure for what? Broadcast and multicast traffic reaches all the devices with the broadcast within the broadcast domain. Suppose that in a VLAN 1, okay, we have 2000 of users. If multiple switches are connected here by using trunk port, okay, then what it will do? It will share their broadcast only these those interfaces where it is actually where is VLAN 1. It is not going to share on VLAN 2, VLAN 3 or XYZ, anything, any VLAN. Okay, so it will ensure for that as well. Let me erase all of the time, I have to erase this thing. Then VLAN support. So layer 2 switches can support VLAN as well, like if we want to create multiple VLAN, that it can support, but at a time only one VLAN is going to be work. Okay, we will discuss and we will learn about it in a physical network. Basically you are going to understand. Hope if we will get time some time today, then I will show you how it is going to we work in a in a topology. I will build a topology later. So okay, so layer 2 switch support VLAN, which is a partition of a single physical network into a multiple logical network. For example, this is a good example I am going to share. We have 24 port switch. 8 port belongs to admin. Okay, 8 port belongs to 8 ports are there. Sorry, 32 port or 6 we can say that 6 6 6 6. Then it is 24 port. 6 admin, 6 sales, 6 is for IT, and 6 is for user. Okay, so suppose that if something is there related with admin, then we can, by using the VLAN concept, we can limited our interfaces to share their broadcast entries or share their information in within limited interfaces. For something is for sales, then it will be a only limited interfaces for 8 or 6 interfaces. Similarly we have like what is that, IT. Okay, so IT users can be connect and they can share their information within their LAN, and because of that it is not going to share all information to this in this VLAN, the user VLAN or sales VLAN or admin VLAN. It is only going to be participate in this VLAN only. It is not going to be participate in other VLAN. Okay, so this kind of the thing can also managed by layer 2 switch. VLANs enable VLAN enable support switch layer 2 to work for what it is supporting us to create segregation or and for partition as well. Okay, so VLAN enables network segmentation, isolation, and security by logically separating traffic into different broadcast domain. We already discussed, like if we have 24 port, then we have separated it in 4 ports, 4 different group. Okay, so these kind of the thing can be happen, and if it is, if we want to do, then we can use VLAN for segregation. Then there is a spanning tree protocol. Spanning tree protocol is what, you see that I draw 3 or 4 times and the similar diagram. Okay, like we have switch 1, switch 2, switch 3. Suppose that something there is connected, that is connected through a trunk. This is trunk interface basically called. Okay, to share all kind of VLAN traffic between, so switch 1 to switch 2, switch 2 to switch 3, switch between within a network. Suppose that what is happening here, by some reason cable got broken, or by some reason interface got shut down. Then what will happen? Switch 1 traffic, suppose there is a user, there are 3 users on different location, they are in the same group. They are admin actually. Okay, admin, they are sharing some information, and during this info sharing data, cable got broken. So then what will happen? It is not going to participate from source to destination. Either it is sending from here, first switch to second switch, or second switch to third switch PC or administrative uh, PC. Then what we have to do, we can put another cable between the switches. So to return for redundancy purpose, like if suppose that something, if in case one cable is get broken, or switch interface goes down without any logic, or we can say that someone by mistake, someone he did, he just shut down that interface or trunk interface. Okay, then it will help us to share information without losing our time, or our network resource will be always up and running. So suppose that if some traffic is coming from this PC. Okay, let me change the pen for now. Something is coming from this PC and it is sending to the switch. Okay, how it is going to share? And then it will share information to this switch, this interface, and as well as suppose that there is a PC connected except on this interface. Okay, then how it is going? It is passing to the switch, to switch. Okay, and what it will do, this packet will send to the switch, and this packet will send which is coming from here. Okay, so what it will do, suppose that something is coming from this line, it is going to be shared on this interface, and if it is incoming, then it will be other different switch. So it will create a loop. To prevent this loop, here what we are going to use here in in our network, a spanning tree protocol. A spanning tree protocol, what it will do, it will allow us to reduce our network broadcast, or it will allow us to make enhance our switching capacity for users. Okay, so layer 2 switch implement a spanning tree protocol, or it is a variant such as rapid spanning. There are multiple spanning tree protocol in the network. That is rapid RSTP, MSTP, which what we are going to use. Okay, so that's you already understand about it. So it is going to create a loop, and till then we have it is not it will consume all of the bandwidth of that interface, and communication will be stopped from source to destination. Okay, to reduce this thing, we have to use what, a spanning tree protocol. Okay, so then we are going to discuss about next function of our layer 3 switch, that is link aggregation. Okay, link aggregation. So how link aggregation or ether channel is going to work? We already drawn the diagram. Okay, in the last slide, we have switch and we have connected two interfaces. Suppose that this interface belongs to 100 mbps, and this and we have 100 users, 200 users in this segment, or this is a building. There are 200 users, there is also 200 users. Okay, or suppose that there is 100. Let's take an example, 100. Then what we will do, if suppose that they are sharing in data from this building A to building B, and then what will happen, it will share information. There is not an issue, but it will create what, it will create something like it will laggy. Suppose that sometime it will send 1 mbps traffic, and sometime it will say 1 kbps traffic, or 1 kbps data. To reduce this thing, we can use ether channel. Ether channel can do one thing, it can bundle the interfaces into a single link by using single link. Either it is trunk, so it is also helping us to for redundancy as well. It is also adding one thing, what that is, it is increasing the bandwidth. Suppose that this was interface was 100 mbps link, and also we have connected one more interface that is 100 mbps link. Okay, so now what is the bandwidth, total bandwidth of our connected switch connected link between switch 1 and switch 2, that is 200 mbps, and user can share information like 1 mbps for example, without any interruption. Okay, so this is this kind of the thing done by link aggregation or ether channel. And it is also, we can configure that link as a layer 2, sorry, trunk port as well. Okay, so layer 2 switch support link aggregation or ether channel, which combine multiple physical layer link into the between switches. Okay, so this is just I'm taking this slide just for reference. Suppose that if you are not going to understand my voice or something, it is lagging, in that case it will help you to create a note for you. Okay guys, then link aggregation increase bandwidth, we already discussed. Enhance network reliability, because suppose something is getting one cable is get broken or down, then in case it is also going to work similar as a STP. So, and it is also setting the load balancing based on MAC address. It is taking decision. Suppose that something is from AA MAC address or BB, so it is going to discuss. So bandwidth increase for that thing. We will deep in dive in a few after few video, after few lecture. There is a separate topic of ether channel. So till then you guys have to wait for it. So how it is going to work, we will discuss on a very brief in that, because of layer 2 switch we are discussing today, so we are not going to take that thing here, because it will be totally lengthy. So then there are some features as well. It's called port security. So what is port security? Suppose that this is a switch, and there is a users are connected. One day, one desk, this is your desk. Okay, you are not on your desk and you are on absent leave for some reason. Suppose that someone came from outside and your security guard did allow him to come in your premises, in your office premises, and what will happen, what he did, he just connect here his or his laptop in the network plug cable, sorry, network IO port, it's called input output port. And what it is he's trying to use that in their, use his laptop as a DHCP server or FTP server, something else. So to steal information about like credential, user information, user data, or something which is very important for your organization or your network. So by using port security, what it will help us, it will we will bind what, bind MAC address on the port. If something, if the user suppose that your MAC address is XYZ, okay, and something, and his its MAC address is ABC. So we will bind uh, XYZ on port number. Suppose that this is your port number FA10/0/10. Okay. So we will bind XYZ on FA0/10. If something is if someone is connected their PC on this interface, if it is not matching the MAC address, then what it is going to do, it is going to be error disable or blocking state. So we will also configure, this is a part of our CCNA course, so we will discuss there everything about it. So basically it will, this is just a feature to enable like MAC filtering, it is also called like MAC filtering. If it is not based on that's why I explain everything about how it is going to work. So okay, so if it is not going to be check it, the packet is not coming from that MAC address particularly, then it is going to be blocked by the switch. Okay, like it is using like DHCP attack or something, so it can do by them. Then there is a storm control. Storm control is what, suppose that some DHCP, there is an attacker, it was trying to sending information about DHCP packet multiple times. Then what it is creating, what it is creating, and the broadcast packet and multi broadcast, okay, in the switch. And because of why it is doing like that, to consume all of the bandwidth of this interface. Either it is 1 gig, 100 MB, 10 MB, whatever it is. So suppose that there is something storm, it's called like flood. Okay, so if there is it the user is sending something that is not a new for use, and it is what it is doing, it is just consuming our interface bandwidth or connected interface bandwidth. Then in case we are going to use a storm control, so we will, what we will do, we will configure a storm control on interface. Suppose that if 80% bandwidth consumed, then it will discard the it if something is there connected on the switch, if 80% bandwidth its uses of this its connected interface, then it is going to be block that interface. So look like that it is going to work in our network. Okay, so a storm control is a mechanism of layer 2 switch. Okay, so what it is going to do, it's mitigate the broadcast, multicast, and unicast storm by limiting rate of incoming traffic to prevent network congestion and disruption. Okay, hope you understand with the example what I said. Then there is IGMP snooping. IGMP snooping is that internet group management protocol called that. It's called internet group management protocol. So it is doing it is also in a snooping. Okay, so it's listen IGMP messages exchange between host and multiple routers. Something if that is not related to the router, it is going to be discard. Okay, then there is loop prevention mechanism. Loop prevention is a similarly like STP, or there was a loop prevention mechanism, but there is also one thing called BPDU guard, Bridge Protocol Data Unit. It is what it is doing. Suppose something is someone is trying to make their laptop or devices or workstation as a root bridge. In that case, it is going to be used to prevent our network. So it will also prevent our network. Okay, by enabling, because we know we can configure our STP root port, and we can change their values at a time, like if it 32768 and if we want to configure change the root queries id, then we can do that priority as well. So because of that reason we are using bpdu guard. If something is coming bpdu guard, then it will going to be blocked. Then there is virtual stacking. So we will what is virtual stacking? Suppose that we have multiple switches. Okay, switch 1 and switch 3, there are three switches for example, and it is just we want to manage as a single by using single management interface, or to reduce our ip addresses as well as management console. So in that case what we can do, we can do virtual stacking of those switches, so that we can manage this switch by using single console or some and it will also help us to create a single database. Okay, some layer 2 switches support virtual stacking or stacking, but this is depends on their configuration or based on model. Not every switches are going to support this thing. Okay, so either it we can use for virtual stacking, that is ethernet, or there is a stacking cable. Okay, so we can use both of the thing. Let me show you an example how it is going to be look like and how it is showing. So here you can see the virtual stacking is it will look like this. So here you can see this is switch 1, switch 2, switch 3. Here you can see this is the port of console port. There is a console port and management port. Console port and management port, there are two ports. But what will happen if suppose that we have to this is on a single rack and we want to configure at a time, then we have to use this kind of thing. So this interface is called stack interface. Okay, okay, so how it is connected? This is connected from this pc1 to pc2, sorry, switch 1 to switch 2, and then switch to switch 3, and then switch through switch 1. And after that this is called in a single virtual switch. Okay, single virtual stacking is this, and we can manage this switch by using single console or single management ip. Okay, here you can see this is the usb. If we want to upgrade the switch, then we can do upgrade from here as well. There is something looks like that. So guys, hope you understand. We already discussed 1 hour on the switch, and after that we have to go for layer 3 switch. So if you guys are agree, then you can take off a 5-minute break, so that basically it is lengthy and we are going to discuss everything in a deep. So just take guys 5 minutes, and I'll come in 5 minutes at we will meet at 10:05. Almost 10 minutes we have. Sorry, 9:05. So okay, if you have till then, if you have any question, please chat us, and let me come after the break, and I will discuss on it related layer 2 switch, if you guys have any issues or any concern about it. Okay guys, let's see you after 9:05. No, meeting is not paused. I was waiting. So can we start now? If you guys are available here. So let's start because I came back. If you want, then I can wait for a minute as well. So just let's go to the next section of our layer to switch. Okay. So first of the thing, there are some use cases of layer 2 switch. That is basically this is lengthy. I am going to discuss everything, so it is taking time. Okay, it is working. Okay, yeah. So there are some use cases. So first use case is local area network. So local area network, we discuss about it like it will be a single broadcast domain, and everything which what we are going to discuss, share information. Suppose that PC1 is and PC2 was sharing their information in a single domain. S- okay, so in that case it is going to it will be a part of, suppose that this is a belongs to VLAN 1 and this is also belongs to the VLAN 1, so this is a kind be a part of local area network, a single local area network. Okay, and layer to switch are commonly used in a LAN environment to interconnect computer, printer and server. We will already discuss about it, so just I am going forward. Then then we have edge switching. So what is edge switching? Edge switching is a different concept. Let me show you everything. So let's switch layer to switch servers. What it is going to be servers. It can be it can work as a layer switch, edge switch as well. Okay, in a network architecture, connection end user devices such as desktop computer, laptop, IP phone and wireless access point. Why it is called edge? Because this is just entry point of use for users. This is entry point for every users. So because of that, it's called edge switches. It this technology called edge switching. Like we will see there is a edge router. Okay, we will see in the sometime. So this is why it is called edge router, because this is front of internet. Because of that, it's called edge router. So similarly, which is nearest to the user or nearest uh, which where multiple things are coming, that traffic is coming, so it's called edge actually in the network. They provide connectivity device to device at the network edge and enforce network policies and security measures at the access layer. Basically access layer is layer uh, access layer is the that layer. Suppose that in architecture, like we have three architecture, three tier architecture: core, then there is distribution, and there is access layer. Okay, so it is going to connect every switches, and let me change the color of pen. And okay, so this is called layer, access layer. Okay, so the as access layer, this is called edge switch as well. Okay, hope you understand about it. That's why I make the diagram. So devices can be connected directly here. Devices are connected directly here. Suppose there are multiple users, they are connected. You understand, I think. If not, please you can ping so that I can share. I can let you know again. If yes, then we are. I'm going to for. I'm going on next slide. Then how it is, there are IGMP snooping, we already discussed about it. Then we have what, distribution switches. So distribution was that on the already discussed on where layer 2 sorry, there was three tier architecture: core, and there was distribution. Okay, so distribution, what it is allowing us, it is allowing to share to connect multiple access or core switches between them, because it is good to be it is going to be a participate, look like how it is going to be participate, like this is a just a building, and this is a campus. Okay, this is a whole campus. this is a building, and in this building there is a class. For a campus network, if we are talking about, this is building, this is campus, and this is class. So you just understand like that, there is a big campus or 100-acre campus, there is a building in 10 acres, and there is a class in 1 acre, for example. Okay, not acre, acre is a really a broad area, wide area. So just for example, so this is a class is basically access, belongs to the access layer. This is in the distribution layer. Okay, so in a building there can be a 10 class or 100 class. As per requirement we can build the classes. So this is kind of, this kind of technology called distribution switching here. Okay, so it is what it is going to distribute, it is going to distribute the network, the core layer information, or going to be distribute this network into 100, 10 or 100 different switches, two to different switches. Okay, so this kind of the technology called this destination switching. Destination switching provide connected between access, connectivity between access switches. Here is a mesh switching. Okay, so you understand about it. Then here our layer 2 switch is completed. So if you guys agree, then we are going to talk about layer 3 as well today, because we have already scheduled for that. And one more thing, you guys were asking about how we are going to see the recordings. Okay, so let me show you how we are going to see the recording. This is the YouTube channel, com and slash at the rate networking scholar. I'm sending I'm sending link in the chat. Here you can see we are live already, we are live, so it is showing also in a live. If you want, then you can go in the live stream. I am just copying the link and I'm sharing you with guys. If it will not show you, you can let us know. As well as this is our channel link, and networking scholar. Okay, so I'm control C, and this is the link of our YouTube channel. You can subscribe it for you will get the notification as well. Okay, and if you are enrolled, you have already enrolled yourself in the course section, then you can go with the course section. Okay, let me go with the other account so that I will show you. Here you can see this is networking scholar website. Not this is not. Let me show. Mm. It is lagging today because I am streaming multiple, I'm using multiple desktop, and okay, it is not showing. Let me check, let me refresh it. So let me show you how it is going to look like. You have been logged out. Okay, no issue. Continue with Google. You have already, if you have already enrolled, or if you haven't, then you can go for the sign in. And I am using this account because I was using earlier. I think there is something issue with my that credential. Let me go with this. I'm going to the library. I think I have already subscribed the course. No. Okay. So here I am going on Networking Scholar again to subscribe this course. I don't have active courses here. You can see. Okay. So this is the free webinar session where we are working. And here you can see the day 3. You will get recording there. Let me show you the day 2 recording. So this is day 2 recording. Here you can see the recording is there, and you have to just click on view recording. Class already ended on the last week, as well as you will find if there is any kind of notes. So you are going to find this kind of note here from here. Like this is the document for how to download from where to download Cisco packet tracer basically. So it will give you the link to download Cisco packet tracer. So in this session, it is not allowing us to copy the link. Let me share you the link so that you can download Cisco packet tracer as well. Control C. Clear all download, remove everything, and I'm not going to save it. Open download page. Plus. So you are going to check. You are going if you are trying to download, and if you are going to check the recording, so you will get the recording, all of the recording here. If you have to just click on view recordings, and you will get the recording here. Everything is here, okay, in a clear voice and everything. So whenever it is going to process, suppose that we have taken 2 hour classes, so after 2 hour or 3 hour you will get the recording. Okay, so I'm just okay, I have just closed that. So hope you guys understand. If you are watching on YouTube and you want to see check the YouTube videos, then you can use this. And there is also important topic for networking, so you can subscribe this thing. These 3 courses are totally free for you. Okay, then let's go to the next session of our course, that is layer 3 switches. So we already discussed layer 2 switches, so multiple thing will come into the layer 3 switch. So that will be similar as a layer 2. Either it is interface, port and port security. There are something different things. So what we that thing we are going to discuss here in this session. Because why we are not going to discuss all of the thing which was because switches are similar, they are working similarly. They are going to build a similar databases on layer 2 switch and layer 3 switch as well. But there are something different, some things are different. So we will discuss only those things here. Okay, so layer 3 switches, so how it is going to work and what is actually layer 3 switch. Okay, so layer 3 switch is also known as multi-layer switch. Why it's called multi-layer? Because it can support layer 2. Based on decision layer 2, it can take decision as well as layer 3. Okay, so okay, and it has also one capacity to share routing, for routing as well. So it can do routing as well. Okay, quality of services is it can also do. So routing capacity is there, and it has also features like layer 2 and layer 3. So we already discussed about it. So layer 2, how it is going to work. Then we are going to discuss in this session about layer 3. So how what is layer 3 actually? So layer 3, this me it is adding additional thing that is based on MAC addresses. Okay, let me erase it. Layer 3, what is layer 3? On the layer 3, that is network related thing. So it is going to be take decision based on layer 2 as well as MAC address and as well as IP addresses that belongs to the layer 3. Okay, so it will take decision by using MAC address and IP address as well. Here you can see this is the image of layer 3 switch or layer 3 switch. Why? Because there is a console port as well as upgradation, and there are multiple thing which we can do. This is as SMB series switches, a small medium business series. Okay, SMB switches are these are the SMB switches. Here you can see these are the interfaces, similar, everything is similar. There are SFP port, these are the SFP port. Console port you can see in the front. There is USB port. This is also called console port. Okay, there is a reset button. These are the SFP port. These this is non PoE. And you if you are asking about how it is, why it is non PoE, in every PoE you will see the yellow strap in the below, where which interface belongs to the PoE, power over Ethernet. If there is not yellow strap or yellow line on their on the numbers, then it's mean this, that is non PoE switch, and this is PoE. Okay, this is non PoE, PoE. This is non PoE and PoE. So it is look like. So here you can see all of 6 switches, 3 are PoE and three are non PoE switches. Okay, so let's move forward on the next thing. So components of layer 3 switch. So we already discussed in the layer 2 switch what is switch fabric, how it is going to work. So it is quite similar as a layer 2. In the layer 3 it is going to be work similarly, not it is going to be take anything advantage or disadvantage there. So everything is same. Okay, here we already discussed about ASIC and FPGA. So it is similar. Then there is a port. So ports are similar on layer 3 switch as well. This is called physical ports are called ports, and it can be a 100 meg 100 and megabit port, or 10 gig till 100 gig to 1 GB, 1 GB to 10 G, it can support. So based on the configuration layer 2 and layer 3 layer 3 we can define the ports. Either we can use that port as a layer 2 port or layer 3 port. It depends on your organization policy as per your configuration, as per your demand. If suppose that if you have to use this interface as a layer 2 or layer 3, then you can use it. These interfaces can support both of the layer 2 or layer 3. How layer 3, if we want to enable IP address directly on the interface, then we can use it, okay, as a router. Then there is CPU and memory. We already discussed about CPU and memory, how it is going to be look like and what kind of the thing it is doing by the CPU and memory. And then there is next thing, that is routing table. Routing table is important. Why routing table is important? In the last section of layer 2 switch we learned about MAC address table, but there is routing table. Routing table, it is maintaining a database based on their IP addresses, IP routes. Okay, so layer 3 switch maintain routing table that contain information about router and next hop IP addresses. So this is a feature of our layer 3 switch basically. Because of that it can use as a router as well. But there is one major difference between router and L3 switch, that is layered router can do NAT, but layer 3 switch it's not going to do NATing. That is the only one thing we can say, that this is the major thing which can't support layer 3 switch. Otherwise everything is similar as a router. Okay, so it can contain information from based on IP addresses to the next hop addresses, next hop available addresses, whatever it is. Suppose that we have layer 3 switch and there is a two VLAN, VLAN 1 and VLAN 2. VLAN 1 is 172.1.1.10/24, and this is 172.1.2.0/24. Okay, so if this this network user, VLAN 1 user, wants to communicate on VLAN 2, then it can happen by using layer 3, or sorry, layer 3 by using layer 3 protocol, that is routing. And it is also making a database, that is layer 3 data routing table, because it will get information in how it will going to be make a routing table. It will create similar as a MAC address table, port and connector network. Okay, or destiny suppose that this is FA0/2 and FA0/1. Okay, so it will create FA1 it is connected through 172.1.1.1 and FA2 2.0/24. So suppose that something is coming from 1.0/24, it can go and it want to go to the 2.0. So it will take decision based on their interface as well. Suppose that we have connected multiple switch over there on in the different side interfaces. So it can do it can share the information to the destination interfaces. Okay. Then there is MAC address table. So we already learned about it, how it is building a MAC address table. No, Vipul, basically IPsec VPN can't done by L3 because this is not a part for now. But if your switch, no, it is not going to be part of that. So basically router, basically layer 3 router in the layer 3, we can say that. So IPsec tunnel is different thing. Then management interface. So management interface is that to configure or manage the switches or monitor or troubleshooting purpose we are using. This is also similar as layer 2 switch. Then we have some functions that is called IP routing. First thing is IP routing. So what is IP routing actually? IP routing is that function which allow to route traffic based on IP addresses. Based on IP addresses, how? Because in the L2 we see that it is forwarding that frame forwarding based on layer through MAC address table, based on MAC address table, and in the layer 3 switch it can take this decision based on IP routing as well. So primary function of layer 3 switch is perform IP routing. Primary, this is a primary function of it. Okay. So which involve forwarding IP packets between different IP subnets or VLAN based on destination addresses. Suppose that we already discussed in the last slide. So if we have multiple network and we want to share, we want to communicate to each other and different nodes or different location, then we can do by using routing protocol. And routing, either it could be a static or dynamic, but if you have routing information, then it is possible. Layer 3 switch use routing protocols such as OSPF, RIP, BGP as well. Okay, it can support OSPF as well as BGP. So we can discuss later in when we were going to discuss about layer 3 switch, configure layer 3 switch. In that time, we will discuss in a brief how it is going to be configured. Either if we will learn about OSPF or RIP, in that time we will discuss about it. Okay, in the brief. So first of all, you need to understand. So it is just building, or it is getting information from OSPF routing protocol or RIP protocol, for example, and it is creating a database for routing. Okay, then there is inter-VLAN routing. Suppose that if we don't have router, okay, we don't have router in our network, and but we have 10 VLANs. Okay, VLAN 1 to VLAN 10. Okay, and what it is going to do, suppose that there are 10 users and every user is from different VLAN, and they don't want to communicate to each other. Or if we have 10 user and if they want to communicate to each other by using different VLAN, then there is only one possible. Either we have to create a connect or router between them, and we have to create sub interface on the router so that it will be a gateway of every network or every VLAN. Or we can do inter VLAN routing on the switch, on the Cisco switches or devices, so that what it will do, it will allow us to share information information or packet from one VLAN to other VLAN. Either it is VLAN 1, VLAN 2, VLAN 3, XYZ. Okay, inter VLAN allowing device in different VLAN to communicate with each other, forwarding IP packet between VLANs. So based on that, we can share, it can share information from one VLAN to other VLAN, and it can communicate easily. Okay. Then there is dynamic routing protocol. So dynamic routing protocol, we already here you can see the OSPF, EIGRP, RIP. So dynamic layer 3 switch can participate in dynamic routing protocol, learn about network routes, make routing decision dynamically. if we have multiple network and it is trying to share communicate with different kind of different network, so in that case dynamic routing protocol is a part which is learning route dynamically, and allow us, it will help us to share information dynamic based on their routing table. Okay, routing protocols, dynamic routing protocols allow layer 3 switches to adopt to changes in the network topology. Suppose that if the something is getting down or some network is getting down, then it will automatically remove those entries which is down or which is up. Okay, then such as link failure, network exception, expansion, or update routing table accordingly, and it will update routing table. We'll discuss in routing it in brief. Then there is a static routing. Suppose that we have few VLANs. Okay, or we have a PC here that is connected the server. Okay, basically this is a server, and we have a router, and it is connected through internet. Okay, and there on the internet or behind the router there is a user that is connected through your VPN user. It's want to connect this server that is 10.1.1.100/24. 10.1.1.0/24 is this, and the IP address of switch 2 is 254. Suppose that if you there is a VPN user, it want to access what? It wants to access 1.100, 10.10.10.1.1.100. In that case, what it will create? It will connect to the VPN, and it will access. But how? If it's don't know about how it is connected, so what we will do? We will create a static routing between these devices, because we know this is a part of VLAN. Okay, so what we will say, this is your gateway, this is your gateway of VLAN 1. Suppose that we have also VLAN 2 here. If there is, this is an example, and we have VLAN 2 here also, and the IP address is 20.1.1.0/24. Then what will happen? We, if till then we don't have static routing information or routing information, it is not going to be participate. Suppose that there is a file. Okay, and it's want to and remote user want to access this file, then it is all, how it will come, it will come look like that, to create a file. But how it is going to share that file? Packet is came definitely, but it is only going to send that their packet, because there are multiple VLANs configured on the switch. So it is going to send their file or that packet to their gateway, and on the gateway it will check for the upcoming incoming packet IP addresses or destination IP addresses where it's want to go. So it will check for that, and it will share that information to router, and router will share to the VPN user. So look like that static routing is working. Suppose that uh, if we have a packet, we will discuss in the routing section, but let me show you. If we are using the command IP route, if anything is 0 0 0 0 0 0 0 0, and then get destination address will be 10.1.1.1, the IP address. If anything wants is coming from anywhere, and if we want this PC wants to share information, then we are you have to share your that packet or data packet or that file to 10.1.1.0, and 10.1.1.0 is a router, and router will take decision as per their routing table or as per their connection. Okay, so look like that it is going to work, static routing. Okay, then there is such kind of quality of services. Quality of services is a different thing which we didn't learn about it in the layer 2 switch. So quality of services is that it is allowed it will prioritize the traffic, network traffic, based on their uh, some kind of features, that either it is IP procedure, DSCP. Okay, why you are using the quality of services? Suppose that we have a video conferencing devices or video call devices or video streaming devices. In that case, we can use quality of services to limit the bandwidth of those particular devices or interface. Suppose that if traffic is coming one sharing between data to data, then there is not an issue. If suppose that some traffic came for video conferencing, in that case quality of service is going to play a role. It will, what it will do, it will check for the bandwidth, and it will allocate the particular bandwidth for the in that interface to share like a video streaming to the destination devices, and improve call and video conferencing, etc. Okay. Then there are security features. Security feature we already learned about port security, but there are different thing that is called access control list. Port security we already learned. DHCP snooping can done by here. IP source guard can be done by here against IP source guard. Why you are using security features? To prevent our network from unauthorized accesses. Suppose that it is some users came to your network and it is trying to steal some information of your network. Either it is a uh, sensitive information of your company, sales information of your company, or it can be your client information as well. So to prevent that, we can use ACL, we can use port security, DHCP snooping to prevent our DHCP server and the DHCP IP addresses, IP source guard, so that if the IP is this is the particularly based on security features. So suppose it is coming from a particular source, then it can check for that only it is allowed those traffic which is allowed. What is ACL actually? Okay, so ACL is that it is create a policy, like if the user is A and it's want to go B, it is allowed. If user is A, it's want to go C and it is denied. So based on that, if we can make a access control list. Okay, uh, in the switches, and it is supported by layer 3 switch only, not layer 2, because layer 2 is not going to understand about the IP addresses. Okay, so we will build ACL in the security feature. That is our next sixth fifth topic of our fifth point of our CCNA syllabus, CCNA 200 and 301. So okay, ACL we will going to learn about there. So just I explain how it is going to work. Then there is high availability and redundancy. High availability and redundancy is similar like we learn about uh, ether channel. Okay, so how availability and redundancy, how it is going to work? Suppose that we have two switches. Okay, and two switches, this is core and this is access, and it is connected through a router, and router is connected to internet, and there are few users are connected. What will happen? What if this switch is getting failed? Not nothing is going to be happen. Not communication will be established between internal user to out internet, internal user, in essence user to the internet. So in that case, what we are going to use, we are going to use an additional switch or a high availability devices for redundancy this network. And what it will do, suppose that this switch is getting down, then traffic, traffic will forward, how traffic will forward look like that. Okay, it is not going to interrupt our network. No, not any user going to face any kind of issue related network or bandwidth or something look like that. Suppose that this switch goes down, in that case traffic will go like that. Okay, if this interface go down, everything is up, then what it will happen, it will share information like that or like that. Based on our configuration, we can manage high availability in our network. Okay, redundancy by you there are few protocols which is used for redundancy, that is called HSRP, host standby redundancy protocol, or gateway load balancing protocol. There is also one protocol, that is virtual routing redundancy protocol. So these three kind of protocol we are going to use in our HE, high availability. Okay, the, this is just a failover mechanism. It will always help you to protect your network against any kind of failure if happen. If not, then everything is good. But this is costly to you because you have to use that high end switches, because it should at least capture all of the data, all of the packets at the time when source user is trying to send something to the destination user. Okay, then there are some more features about the IP based layer 3 switch, that is IPv6 support. So IPv layer 2 switch is not supporting any kind of IP addresses, but it is going to support by IPv6 as well and IPv4 as well. Okay, on the layer 2 switch, layer 3 switch. And there are one more thing that is important. It is also supporting policy based routing, PBR. Suppose that if we have configured something on the device and we want to route the traffic based on their policy, in that case we will make that we can configure PBR on the switch, and it will allow that packet to transfer as per their policy. Some layer 3 switches support policy based routing, which allow administrator to define routing policy based on a specific criteria such as source IP address. It is similar like ACL. Okay, so A wants to go communicate B, allow. A wants to communicate C, deny. A wants to communicate D on port number 8080, then allow, and 8090. Okay, 8080 allow, 8090 deny. So it is similar like that. Based on policy, it is going to work. So this was the feature of our layer 2 and layer 3 switches. If you guys are okay with it, then this was the last slide of our layer 3 switch. If you want to know about how we are going to configure VLAN and how the traffic will pass, so I can let you know if you guys are okay. Otherwise, we can bind up this session by today here, because we already discussed multiple things. If you guys have any question related L2 and L3 switch, you can ask. So if you don't have any question, you can just ping you don't have question, so that we can stop this session here, and we will discuss tomorrow. For tomorrow we have another session for IPS, IDS, and next generation firewall. That is really important thing of network. Like it is going to protect our network, how it is going to be work in the network. So we will discuss tomorrow. So hope you guys already watched this video and from beginning to end. And if you haven't enrolled yourself in the course, for you can follow this kind of link. So this is the link for a website. This is a link for class will be start at same time at 8 p.m. because it is Saturday and Sunday. So Saturday, Sunday, we are going to take 2 more day session, because we have planned for a 5-day free CCNA workshop. So this is today's day 3, and tomorrow will be day 4, and day after tomorrow it will be day 5. And this is the LinkedIn. You can join. This is YouTube, and contact us how you are going to work. Okay. Hope you guys understand about the layer 2 and layer 3 switch. So if you are agree, then you can please subscribe our channel as well, and you can chat there, and you can please share your feedback, so that it will help me to improve my content as well. Okay, because sometimes what is happening, I am also getting because some technical issue, I'm getting it voice is getting lag. If there is anything related with that, like voice content, or if you don't understand about it, so I will let you know, and I will help you in that. So this was the thing. Hope you guys understand about how you have to enroll yourself, because it was my account and I am already installed in enroll in Networking Scholar. And you can see here there are 2 upcoming classes and 1 ongoing classes, which is this one. This class is ongoing. And if there is something important like a VPN session, or we are building any kind of VPN, or we are implementing something in our network, or either I am in my network as well where I am working, or I'm doing some kind of activity in that case, it is the course where you are going to all kind of update. And hope you guys must go with this link, and you can download the packet tracer from uh, directly netcat.com. And you can also watch this video how to create your Netcat account, how you can download it, how you can going to create Netcat account, how you are going to log in, how you are going to configure a switch or something. So you can watch this video in this course section. That is a free playlist, YouTube playlist. You will find videos there. You can watch this. please scholar link. So let me share you the scholar link back. Basically this is you can people you can go on the Google Chrome or any other browser and just go search networkingscholar.com. In the networkingscholar.com you will find the course section there. Okay, let me show you. Networkingscholar.com is there, and you will find the course section. In the course section you will find these three courses which is totally free. If you want to join our upcoming session for CCNA in English or Hindi for in a detail for everything, including uh, interview session as well as how to build a CV, AI and everything, so you will get there. Okay, so this is the course section, and in the course section you will find some, there are some free. You can filter it as you can enroll it yourself as per required. Okay, so this is the link for a store, and let me share you the link for everyone. Okay, so CCNA networking basic, oh sorry, control X. Okay, this is the link. Okay, so you can enroll yourself and you will get all of the update as well as recording will be available here. Here you can see Kaviraj has subscribed one course or sign up one course from Bangalore about 55 minutes ago. So you will get everything here. Okay, so no need to worry. If there is anything you want to discuss, then there is a community as well. So in the community you will you can discuss everything. You will like course related content, and anything is related with your query, we can discuss over there. Okay, here you can see this is the community of your course. Okay, and if you want to watch this video on YouTube, then you can go and you can watch this video on YouTube as well. Let me go with the CCNA. So this is the YouTube channel. Let me share you the link of YouTube channel. Please subscribe this channel as well, so it will help you if you are no if you don't have application and at all. So in that case it will help you. Okay, so there is already live session is going on. Okay, thank you people. So hope you guys understand about it. If you have any question related our layer 2 and layer 3 switch, you can ping us. Or there is also one channel, that is our additional other channel, that is network Indian Cisco group. If you want, then you can enroll that as well. So this is the other channel. Here you can see this is our secondary channel, and it will also help us to share because we have already some videos uploaded there in during COVID, so you can learn it everything from here. So, and let me show you, let me know you, there are one thing which which is running for we are going to start CCNA as well as as well as firewall, including firewall session. So we will going to discuss everything about Cisco ASA firewall as well as CCNA, and we are going to start this course at 11th of March. Okay, so you, if you want, then you guys can enroll yourself in this course. If there is an you if you are going to find any kind of issue, so you can let us know on by clicking contact us. So guys, thank you for watching this video, and thank you for thank you to all of you to being with me from so beginning to end of this class. And I'm going to stop this class. If you have any query, you can just ping us, and we will definitely